Hello, everybody. Assalamu alaikum. Welcome back. How are you, Java developers? Again, after we took maybe a short break from Eid, and here we are continuing and resuming with our online and in-person sessions. Today, we are doing a little bit shift into the Java ecosystem. We are talking about the modern Java stuff, 23, 24, 25. We have also a special guest who really will appreciate it to join us. Bazlur, Assalamu alaikum.
Walaikum salam.
How are you, brother? Good?
Uh, I'm really good, Alhamdulillah. And the weather here is really good. I'm just
Nice.
waiting after finishing this talk. I'll go outside and you know take some strolling around. Let's see.
Nice, nice. Thank
How are
you
things
very
over
much.
there?
Yeah. Now in Riyadh here, it is the really the peak of summer.
Okay.
So July and August are the peak of summer. Then after that, after August, maybe September, then October, December, the weather is good, really. Yeah, especially in October onwards, it's really good. Weather is good.
All right.
So yeah. So what are you preparing for us, Mr. Bazler? Are you preparing something unique?
So yeah, I have a few demo. Essentially, what I'm going to do is, try to run some codes I prepared and try to explain them as much as I can. So yeah, let's go ahead. So I have
Nice.
prepared some slides, but slides are basically essentially for guiding myself. But this session is going to be pretty much demo driven. So I'll
Nice.
write some codes and I'll show you some codes and I'll try to explain. And meanwhile, if you have questions, feel free to ask questions. I'll try my best to answer my questions. Your questions if I can. If I cannot, obviously I'll say sorry and I'll come back again. I'll share through other mediums. As you probably know that I write a lot. I'm very active in LinkedIn, Twitter, and all the other source of social media. Yeah, so let me try. I'll just
Yeah, sure.
I'll
Nice.
I'll
Awesome.
I'll just try to make an attempt. All right.
Yeah. That's very
So
good.
let's start.
Uh, Yeah, before you start, please, Bazlur, I would like to give a quick introduction about Bazlur, if you don't mind.
Sure.
Bazlur Rahman, he is really the first speaker in Riyadh Java User Group, approximately like maybe 1.5 year ago, when we like kicked off this beautiful Riyadh Jag, and he was happily to accept our invitation. He was the first speaker here. Really appreciated. Thank you so much, Bazlur, again to have you here again. Bazlur Rahman is a Java champion. He is a very, very expert guy in terms of Java threads and a Java ecosystem in a nutshell, in general. If you have questions, guys, please drop down in the box below your questions. And before we get started, let's welcome our guest, and the stage is yours, Bazla.
Thank you very much for warm introduction. Well, the weather is warm. All right. So I'll start with the laying out the agenda. What I'm going to share today. There are pretty much a lot of content we can share since JDK 21. We have plenty of updates, plenty of new features, but then within the time limit that we have, we cannot definitely go through all of them. So I picked a few and then I'll try to show you all of the these items. First of all, I will start with the compact source file. And then I'll try to touch a little bit on virtual threads, the updates essentially. Then there is big update on structure concurrency. There is another interesting feature called stream gatherer. There is also scope value, pattern matching, all those things. And if I have time, I'll also touch on other few demos that I have prepared. But I'll try to keep in the 1 hour window. Let's see how far I can go. So thank you for joining with me. All right. So before starting, let me give you a quick rundown of the Java evolutions since JDK 21. I mean, since JDK 21 was essentially a big release in terms of virtual threads and other few features, but the virtual thread was essentially the largest and significant features. I would say revolutionary features. So JDK 21 was a LTS, long-term release, and then 22 essentially it, came in March 2024 as a non-LTS. Essentially the key theme was stabilization some of the features and added new preview features, but that's what it is. And it has some fixes. Then 23, 24, and now we are on 25. 25 is going to be an LTS, and it's going to be released on September 2025. So it has a few major issues, major versions. And essentially the top one on is for structured concurrency. This structured concurrency has still on the preview feature, but we're gonna see that the API has changed dramatically and it improved. I would say it's much easier compared to earlier. Earlier it was like inheritance based. Now it's a factory method based. It's much easier to use. So we're gonna see all of them. All right. First of all, I'll start with the developer productivity, and this is the essentially a big pain point Java had for a long time, especially when you were going to teach a a beginners how we're going to start. Right. For example, if you start a program like let's say I have created a class over here called hello.java. Now I have taught at university for 2 years, and and also I continuously mentor, right? So what happens is when you start teaching a beginner student, what happens is they have asked questions, and for the beginning ritual of any programming language is printing hello world, right? So if you want to do this using Java, you have to write something like that. Public, then you have to declare the class, and then you have to start with this curly brace, right? Then you have to write main method, all those things, rituals. So essentially, and then you have to write something like this: hello world. I mean, to achieve a little thing, for example, over here, right? We are going to print hello world only on this screen. That's the goal. But to achieve that, we have to go through with a few steps. We have to declare hello, and then we have to write public static void, and also it takes an argument which is array. For a beginner students, it's sometimes a lot of things, a lot to consume, and they'll have questions. What is this static keyword? What is this? String args, and this is essentially a blocking point for many students, so they start to switch. So some other programming languages, for example Python, is just one line. So JDK 25, we now have, with the JDK 25 we now have a easier beginning. You can sort of remove all of this ceremony, so you can remove this, and it's going to be it's just fine. It's going to run. As you can see, it ran. And also you can remove this one. I mean, it's you can also run this way. It still works. And then, as you can see, it's also printed hello world. Now the question is, what if I remove all of this as well for a beginner student? I mean, I don't want to explain class, class package, all of those things. I just want to create a file and start writing. So this is much simpler, right? So again, if I run this, obviously it's going to run. I have tested this, and yes, it did. By the way, I'm using JDK 25 right now. So JDK 25 is not still available. It's going to be in September. So I'm using the early release. So you can use early release as well. It's already available. All right. So this is nice. Really, short, and you can just explain main is the entry point and void is something that doesn't return anything. So this main method doesn't return anything, so that's why it's void. And however, still if you want to print, then you have to use the longer statement like the system dot out dot println. However, we can shorten this as well. So if I use this, now it's also pretty short, and this is the new version of Java, so you can start easy. And you can write another method, say void say hello. You don't have to do anything, like you can just print io-println hello, and you can call this from here. Sorry, not synchronized. Say hello. What if you want to declare a variable? For example, you want to declare a variable to let's say int age 19 or something like that. You can do that, and you can access this variable from anywhere in this method. And to make the program more useful, sometimes we need certain special classes. For example, you need list, you need collections APIs, all of those things. You can use them all of them even without specifying the imports. So interestingly, all the utils, for example list, set, and all of them are also available over here. For example, if I can use, I want to create items 1 2 3 4, I can declare something like this, and to explain the beginners, you can just use var. That's much easier. And as you can see, I have no import statement over here. It's just easy. All of the list, all of them are available automatically over here, and I can just run it. So this is the compact source file. You can do scripting as advanced users, but if you want to teach a beginners, it's much easier. And also, interestingly, there is a few other methods available on IO package. It's a special package, specially designed for the beginners-friendly nature. As you can see, it has read line. It has print. We can see the print now. If we want to take a input, we can just say, "Hey, enter your name." It's much more like Python now. So Python has similar methods. I'm not comparing Java with Python, but the startup, the starting point should be easy. So that's the idea. Your name is name. So yeah, that's pretty much it is. If you have any questions, let me know. As you can see, I can take input from the console. It's much easier, just one line, and you can provide the prompt as well over here, and then you can grab it using a variable. You can use var as well if you want to. So those are the things about the compact user file. Let me know if you have any questions. There is a question that I can see over here. Is the instance member without a class? Then what is this? What if for this get class? We can try. You can see it. It's called unnamed class. But let me just make sure what it prints. That get class. So let's see. So as you can see, if you okay, so let me comment this it out for now, and I'm gonna run it again. Okay, so it gets from the file name that we have created over here, which is hello.java. This is the file name. So if I use this .get class, it will be hello. So it automatically will create a class. So yeah, I hope you caught your questions. Someone asked, how long have you been coding? Well, a long time. More than 23 sorry, not 23, I mean 13, at least 14 or 15 years, I guess. I don't remember, but yeah, long time. All right, so hope I have answered your questions, and let's go to the next one. So essentially, the next one is pretty big. The virtual threads, we all know about virtual threads, right? Virtual thread was essentially the revolution since JDK 21. It's a lightweight Java thread. You can create a thread like this, start, thread.start virtual threads, and you can do something like that. And that's it. It's going to start virtual threads, and you can create a millions of them. For example, if you want to do something like this, let's say 10,000, I can create 10,000 virtual thread within within a second. So I can do hello world. Let's say I'm going to print this 10,000 times. It just easy. So I'm going to wait over here let's say 30 seconds, because it's virtual threads all are daemon thread, right? So if main thread doesn't wait, it will just it will go away. So if I do that, let's see, as you can see, it's running, and all of them ran. So it's pretty easy. But there was a problem in JDK 21, which is it's called pinning issue. So that's what we're going to share with you. The idea is when we're going to run a virtual threads grab a grab a thread from fork join pull. Virtual thread is a Java construct. It works like basically a Java object. So it's run on a fork join pull, and fork join pull has a number of threads, which is we called it they're basically native thread, and Java has Java threads are essentially the wrapper of the native threads. We call them platform threads. So what happens is when we start a virtual threads and the function has function pool has let's say 10 threads, right? So these threads are going to run the virtual threads, and when one of them picked one virtual threads, what happens is it takes when virtual threads start executing, and if it sees that there's a blocking operation, it pulled itself from the execution. So the platform then becomes free, and it start executing other threads. So the pinning issue is it cannot do that, so it stays there. So let's say I have a synchronized block over here, right? Synchronized keyword, and I'm going to sleep over here. So if I'm sleeping, that duration of time I'm not doing anything. And the benefit of virtual thread is when it sees an IO operations, it's pull out itself. So now the platform thread is free, and it can execute other threads. And virtual thread, since it's a Java object, it can stay on the heap. It's not wasting my CPU. It's just sleeping over there. But if we had a synchronized block like this, it cannot pull itself. It stays there. So that was essentially a problem in JDK 21. So that would create a performance issue, right? I mean, the platform thread is essentially blocked. So to show that demo, what I'm going to do is I'm going to use JDK 21 over here. I'm using SDK man. It's pretty easier to switch between different version of JDK. So you can use that. So let's see, Java version. So I'm using now JDK 21. What I'm going to do is I'm going to run this program in JDK 21, and let's see. Then I'll explain over here. So as you can see, sorry. Let's see if I can increase the font over here. Okay, so the looks like I cannot increase the font. So I'm going to paste this result over here so that you can see. So over here, as you can see, I'm running 10 threads, and if and I'm printing result for 1, essentially the number 1. And over here, I'm printing the current threads. And then I went to the synchronized block. It's a lock operation, right? And then I sleep for a while, and then I'm printing the same number again for the if it is 1, so I'm going to print the current threads. So if it doesn't there is a slipping operation. Ideally, it is supposed to be pulled out, right? So it's going to be yielded. This is the ideal scenario because it's slipping. Slipping is IO operation. So the current thread should not be the when we started executing. For example, over here we were, let's say we were executing on a T1, right? T1 is a platform threads, and then over here I see a slip operation. I'm supposed to be pulled out, right? I'm supposed to be yielded. And so, and then when I am my sleep duration has completed, I am supposed to go in a different threads because these are all random, right? So that means over here it should be a different thread. That's the idea. It should be different. It could be T1, T2, T3, some other threads. But over here, if I executed that, as you can see, it's remained the same one. So the, for example, one worker one, and also over here it printed the same name. That means it didn't really. So that's a problem. That's a performance bottleneck. And there's a also a JVM argument called I forgot this one, the trace pinned thread. We can pass this argument and see if it really did that. So if I pass that argument, and let's see what happens. So if I pass that argument, as you can see over here, there is a line printed over here. That means it got pinned in the platform threads. So I'm going to paste this over here so that you can see. Sorry about that, console. Okay, as you can see, it did. There's a you can do run it. The argument is text short and full. Full is basically essentially it's a longer text. So I can show you that as well. Full. So it will give you the exactly where it got pinned over here, line number 17. So now what I'm going to do is I'm going to switch the JDK version to new JDK version, which is 25. It's fixed in 24, so you can use 24 as well. So let's confirm Java version. As you can see, I'm using JDK 25, and I'm going to run the same program again. Let's see. So as you can see, I'm passing the JVM argument over here, but I don't see it printed anything over here. So let me paste it over here. So it started on worker thread 1, and then it slipped. It got we have a slip operation over here, and then it basically yielded out, and so when it resumed over here, it got a different platform thread, which is over here. Worker 8, and there is no message called something like this, which is when it pins the number because we have provided the argument. So that's essentially the fix. So you can use virtual threads with confidence nowadays, and with confidence you don't have to worry about the pinning issue. So that's a fix. That's a huge change. I would say that's significant change. The performance issue that we would otherwise face is no longer an issue. All right, let's see if I have any other questions. So the question is, do the file and socket operation yield the platform theme during the blocking operation? If yes, does that mean we don't have to worry about threadful exhaustion anymore? So the question is, there are various entry point in JDK where the API has rewritten to support the virtual threads. So we just I'm kind of confident that it will not pinned anymore. So if you use traditional API, IO API, it will not, it will work just fine with the virtual threads, but just do an experiment for to be sure. Use this argument over here, which is trace pin threads equal to full, or short, whatever. If you see it's pinning, it should not be pinning, right? You can use them with confidence, but yeah, try it out. Just do an experiment. All right. So moving on, the next big thing is essentially, okay, I covered all of those things, so I'm going to skip this slide. Okay, so yeah, it's a breakthrough. It's eliminated the virtual thread spinning. Synchronized block no longer cause spinning. That's awesome news, and we can just use them. I remember one of my previous organization, we wanted to use JDK 21, but we used to use some third-party library that has written in a way that used to use the synchronized block a lot, and that was causing an issue. That's why we were not able to use virtual threads. I guess now we can do that without any issue. So moving on, okay, so there is some best practice. Obviously, virtual thread is IO bound operations, great for web servers and microservices, but obviously you have to keep in mind that virtual thread is not for CPU intensive computation. It works well when you have a lot of IO intensive work. If you have CPU intensive work, you should definitely use platform threads. Also, there is a new thing called scope value, which I'm going to share with you. Instead of using ThreadLocal, use scope value. ThreadLocal has some side effects, some downside, which I'm going to share in a minute. All right. So this is, if you want to write this is a pretty basic example of server example of virtual threads. You can just use virtual threads. Sorry, let me start. It's probably okay. So I'm going to skip it, but the most interesting part is structured concurrency. That's I'm really interested to showing you. So let me start with some problem with the basic traditional traditional concurrency, and then I'll share with you what's the better approach with this structured concurrency. All right. So let's say we have a basic operation over here the old way, right? We were going to process order, and we have executor over here. So all of those things, fetch users, check inventories, and process payment, right? All of them can be run parallelly. So we are passing them in executors with the submit method, fetch users and check inventories. The problem with this approach is they are independent. All these threads, essentially, this will run in a thread, let's say T1, and this is probably going to run on T2. This is going to run on T3. Now, our cases is, let's say I'm going to use fetch user, but what if this fails, right? If user is in a fetch user method fails, then there's no point of fetching this three. The other methods, right? What I will do with the check inventory at this point, if I don't have a correct users. So there is no way to synchronize this process. Now, this is going to be executed anyway, even though this particular one is throws an exceptions. So these two threads now executing taking resources, and they're just they become orphaned, I would say. There is no point of running them, but there is no way we can synchronize them right now with the traditional approach. We have to either keep them failing, and we could do synchronization, but that's become there is a way of doing it, but it's going to be extremely difficult, challenging, and not a super easy way, I would say. So that's a problem essentially. What we want over here is, if one of them fails, then I want to stop executions or other tools. So I'm gonna just stop there. Also, I want to see in the thread in the when I'm gonna take the thread dump on the I want to see a hierarchy. As I want to create a parent-child threads. For example, the process order is going to be invoked by a thread, and then I'm going to create a child thread right over here, fetch user, check inventory, and process. So I can see an hierarchy. I want to see the hierarchy so that if something goes wrong, I can pinpoint the issue. But with the current system, it's not possible. So yeah. So the alternative is essentially is structured concurrency, creating some structure to the um, threads. So that's essentially structured concurrency offer. There is a let's say if I have the demo over here. Okay, concurrency demo, process order. Okay, not here. So let me see if I have. Okay, so first to structure concurrency. Okay, so this is the one essentially. So I'm going to rewrite the process order in the same again. So what I have here is structure task scope, and there is a method called open, and I will do it inside the try catch. This is how I'm going to do, and it, old way was using yeah, inheritance base. So you have to create instance, and in JDK 25 they have changed it. I was a bit annoyed, but then happy as well because it's much simpler. It has 2 incubation and then 4 preview. So it took like 3 years with the same set of API, and now all of a sudden in 25 it's a new API, but the new API is much simpler. It's a lot less code you have to write, and you don't have to worry about a lot. So what we're going to do is you create structure task scope. There's a new same class, but it has a factory method called open, and then you create a scope. And with this scope, you are going to just fork, right? For example, over here, the scope.fork, and then you pass your methods over here, and then you will get all the subtext over here, and then we'll do join over here. So wait for all to join once. So they're going to use obviously they're going to use virtual threads. That's the interesting thing. Automatically, you don't have to specify. The traditional way is you have to specify, right? We have to create an executor. So you could create traditional thread pools, or you could create new virtual thread pool. It's up to you, but you have to specify the if we're using structured concurrency, they are going to automatically use virtual threads. So you don't have to specify. So they're all going to run on virtual threads. Let's say if I print over here, println the current thread plus thread dot current thread. Let me do this in all 3 so that we can see if essentially running on virtual threads. So yeah, so over here we're gonna wait, and once this is done, we can call in get method to get them. So that's essentially it is. I don't think we have a main method over here, so I can use main over here just like this. Okay, so I'm going to call this run method. This is run. Let's see. So as you can see, all of them are virtual threads over here. If you can see, that's fine. Okay, I say I can increase, zoom it out. So this is, for example, one worker. These are basically virtual threads. So now, what if one of them fails essentially, right? Let's say fetch user. I can do a let's say if true, throw new runtime exceptions. Throwing just for sake of throwing exceptions, right? So what happens is it's going to be immediately halt. So if I run this now, as you can see, it's it got halt, and immediately all of them are cancelled. So that's essentially it is. I can do what I can do is I can do an experiment over here. So how long it takes. So let's say, okay, so there is a failed operation over here, process order. I'm going to skip this for now. So over here, I'm going to take instant instant now. Did I okay, local date time now. What happens? It's why I can't load this. Stand. Okay, so let's do one thing. System get nano times. Okay, so I'm going to do this start time, and I'm going to do system.nano time end time, and then I'm going to print duration. So end minus start divided by okay. So I'm going to print the duration, how long it takes. So first, what I'm going to do is I'm going to remove the check in this one, and all of them takes like between 200 to 500 milliseconds. So let's see how long it takes. So it takes like this much time, right? So I'm gonna print over here. Let's print that's previous time took. Now, if I want to go back and do this, that means it should instantly fail and get back to me. And let's see how long it takes. So what happens is this is going to throw an exception over here. So let me move this into finally block, that's so that I can capture. So I'm going to start this over here. Let's see how long it takes. So it should return pretty fast. Okay, that's a problem. It's not supposed to be. So let's see what really happens. So if it throws an exceptions, so I should not wait. So if I go over here open, so it says wait. And there is an API that we there's a few API. The open takes a joiners. I'm going to get to in joiners in a minute. But what I'm going to do is I'm going to pass a joiners. There is I have passed a new joiner over here called all successful or throw. The idea is I want all of them successful. Otherwise, it should throws. So I'm going to explain that in a minute. But let's see reproduce the case. Okay, so is my demo is broken? It's supposed to be faster. Let's see. There is a few others over here, all successful or throws. Let me see. All or nothing. There is another one over here. Let me see. All successful or throw. Yeah, that's supposed to be the right one. All successful or throw. The idea is either all of them will be successful or not. So the reason is the timing is not appropriate over here because over here we don't have a predictable threads asleep. So all of them are variable. That's probably the reason. So I can dig into more, but I'm going to skip it for now. Just try it out because for the sake of time. We have already spent a lot of time on this. So the idea is essentially the structure task works this way. Structure task open, and you can pass up. There are few joiners available. The joiner is the how it's going to behave. For example, over here it's wait all successful or true. Basically it will wait for all of them, and all of them has to be successful. I mean, either way it has to be over here, opens a new thread task scope, and then so create a default configuration. The default configuration. Okay, I'm going to go into the configuration in a minute, but essentially there is a few joiners that we can control. For example, I have a resting them over here, right? For example, there is a cases where we need to call 3 different APIs, but we want to get the fastest one, right? So this is called racing pattern. So I have called let's say Amazon price service, eBay price service, Walmart price service, and I'm happy only want to get successful as fast as it can. So we can pass the configuration over here called using this joiner any successful result or throw. So essentially, if I run this, if one of them are successful, it will return immediately. So that's when we need the first one to win. And there is a few other one which is called all or nothing. So the idea is I want to uh, get all of them, either all of them are successful or nothing. So over here, right, I have a few things we have to do: user services, inventory services, payment services, shipping services. All of them has to be successful to execute to execute all of them, basically execute distributed transaction. For example, let's say it's a demo, so we can pass in the open method we can pass something like all successful or throw. So we can also custom joiners, so we can create something like that. There is a demo over here. So I have a resilient joiner over here, so I can create custom. Just wanted to show you that you can create a custom. It's this structured concurrency should takes like 2 hours to cover all of them. But since we don't have time, I'm not going to cover all of them. But yeah, so you can create a custom joiner like this. So this is essentially the resilient one. This one is essentially wait for all of them, and then it puts everything whatever we have succeeded, and if it fails, it's also get me the failures count as well. So these are the so you can just pass this over here in the open method, resilient joiners. So let's say there are cases when we need to collect as many information as much we want. We don't want to ignore if it fails, but we want to collect as many as we want. For example, let's say I want to fetch all the news article, so I'm going to CNN service, BBC service, all the other services. But what if one fails? Doesn't matter. I want to get at least some of them. So that's when you can use these resilient joiners. So there is also options to provide deadlines. The idea is I want to wait until these many seconds. For example, let's say I want to make a trade decisions and it has to be fast, right? So over here, so I can pass a deadline over here. So let's say 3 milliseconds. I want a decision within this deadline. If it takes more than 3 milliseconds, I'm just ignore. I'm done from here. So I can pass a deadline over here. So you can definitely pass a joiners. There is different kind of joiners already available. You can just check, and then you can provide a configuration. For example, it's a lambda expression configuration with timeout. You can pass a deadline. It's a basically duration. And then you can also provide the thread factory. Obviously, we're using virtual threads over here. You can use platform thread as well. You can use, for example, if we use platform threads, it's going to use platform threads. So structured concurrency works on platform thread as well, but that doesn't really make sense if you have a lot of concurrency IO driven operations. So you are going to use virtual threads, and you can provide name so that you can see them in the log, so what thread is running, right? So yeah, so this is all about structured concurrency, the new way of doing it. It's a new API, and I'm really excited about it. I have a lot of other demo over here, but I'm going to skip for now. I'm going to share this repository with all of you. You can try them out. All right. So next thing that I'm going to show you, let's see what I have over here. then so this is the old way, and then this is the new way. I just explained that. So next interesting part is stream gatherer. It's a new things and it's new way. I mean, essentially, our let's say, let me open that this file. So I'll go start by over here. So the idea is, we had collector, right? For example, values, we can do stream, right? We have a values over here, list of values. I calculated them, and I can map, uh, let's say, value, and I can, let's say, I want to multiply them two with, right? And then we can collect to list, to set, or something like that. The so this was great, definitely, right? We could do a lot of things, but then collector API, it's the end point, right? It's a terminal operation. You cannot do anything once you have collected them. So and then if you want to do operations on collect, you have to create again another stream. The gather API essentially is your enhanced intermediate operation, basically. So you can do map, right? In map, filter, all those basic operation, map, filter, and flat map, all of those things. But gather essentially a more enhanced version. You can do a lot more than just mapping, filtering, flat mapping, all those things. But it's it's an intermediate operation. So once you do things with gather, you can do again other stuff, the regular stuff, which is map, filtering, all those things. So it's a much more instance, and the kind of things we can do with gatherer is not even possible with the collector. For example, let's say I have 10 variables over here. I want to collect them in a window fashion. Let's say I want to do something like this: 1, 2, something like this, right? So it's possible with the collectors, but it takes much effort. With the with the gather API, it's much easier. So for example, over here, there is an example over here, running max. So let's say I have all these values over here, and what I'm gonna do is I'm going to run the high water mark, essentially the running max value. So if, let's say, I have 1 now, and the max is 1, right? And then I have another value which is 5. So max is now 5, and then let's say next value is 2. Still max is 5. So this is essentially how it works. So let me you can do like gatherer.scan, and then you can pass a scan. Let's see what it scan takes, right? So it takes the initial suppliers and then takes a by function. So this is basically a by function. I added as a lambda expression, so you can do this something like that. It's a by function. Essentially takes 2 inputs and then returns 1. So if I run this, let me run that. Let's see what happens, what it returns. I'll explain all of them. So this is the first one, right? So it start with 9, 3. This was the value, and then running max essentially 9, and then obviously the max was 9 until we have 12, and then max is actually 14. So we can do something like that. So this is possible with the scan method. And what if we want to do running product? We can do something similar. So we definitely want to provide the initial value, which is 1, because if we provide 0, it's going to be all 0, right? And then we have over here the accumulator. So this is basically, the accumulator is essentially how far we have multiplied, and then the new value. So we are going to multiply them, and this is going to print the running product. As you can see over here, it did that. 9, 27, 216, 432, something like that. So we can do also complex statistics. For example, we can do fold method. Fold method is essentially if when we need to something, one particular result, then we can fold. And scan is basically it's going to accumulate all of them. So we can do fold, and we have a class called statistics over here. And what we are doing is over here is we are, it's a just simple methods. Whatever value I have received over here, I'm going to count them and get, put the sum of the, put the total of the values, total sum of the values, and then calculate the min max. So we can do using fold method. First one, the initial one, essentially I'm going to provide the instance of the statistics, and then this is the by function. So the by function, I can use the lambda expression. So this is our accumulator. In this case, it is statistics because we are adding value on it all the time, and then the new value. So when new value comes, we are just adding them. And add method takes all these stuff, all the other things, right? And then we are printing them. So over here, as you can see, it printed the count total number was 10 and sum is 79, mean was 2, average was 10. So we can do all those things. So fold is when we only need the final total, final result, then we can use fold. So here's a few other examples. Now we can do more. For, let's say, we can customize, we can use as the way we want. So for example, let's say I have these words over here: the quick brown fox jumps over the lazy dog, and all of these letters, right? So what I want is, I want to do an uppercase, all of them uppercase. I mean, we can do with the map essentially, but we can do with the gather as well. But then gather is more powerful because we can do more complex things over here. So let's say, so what I'm going to do is I'm going to comment it out so that I can build it from here. So word stream and then gatherer. So gatherer, it provides a factory method called gatherer, and then there is an off method. So off method, and it takes a lambda operation, lambda expressions. So in the lambda expression, it takes 3 parameters. There's few other options, but initially it takes a integrator. So if I go over here, that's the integrator, right? Integrator is a functional interface. It has a state, it has element, and then downstream. So what I'm going to do for these cases, I probably don't need the first one, state. I don't have any because I'm just transform them, so I probably don't need to state over here. As you can see, we can use underscore. So if we want to ignore a variable, we can use underscore JDK 25. That's another new addition that I really like. Okay, so yeah, over here I'm going to just do this downstream.push element.uppercase, and then return true because it expects a true return. Interestingly, this push method also return a boolean. So what if I can just do return over here? So this is going to be doing the same thing, and then I can collect them. So I can collect as a to list or first item, whatever way I want. So over here it says object because we didn't specify the type. We can specify type over here. Now this is going to be the string. So it's going to be printed like this. If I run this, so it will print in an uppercase later. Similarly, let's say I have a countries. Let's say I have a country record over here. I'm going to go build over one after one, and then I'll show you that there is already built-in gather available over there. So let's say I have a country over here, right? I have all this list over here, and then this is the city record. So I'm going to flat map them all, right? So I want to get a list of cities. I don't care about countries anymore. So this is how we're going to do. The same way, we can create a flat map or something like that. We create a gatherer and then off methods. We don't care about the first one because it's a state. We don't care about the state, and then so basically it takes the integrator, which is a functional interface, and it has like 3 variable. First one is state, for then the value we are operating on, like the stream API, it gives one value at a time, right? The value, right? Since we are operating on list of countries, so I'm going to get countries, and then there is a another method called downstream. So I'm going to just get all these cities, and then I'm running for each, and then pushing into the downstream. So that's essentially it is. So if I run this, I will see all these cities over here. Now I want to create a method called limit. So how can I do that? I can create a custom gatherer, something like this. So you can create a method. So over here, as you can see, it is a method, right? It takes start from the curly brace and end from the curly brace. Interestingly, you can create a class that inside a method now. So this counter is not exposed anywhere outside. So you can just create inside. So there is a two gatherer provides off, and off is sequential. So for this purpose, I'm going to use the off sequential. This sequential off sequential means this is not going to be possible in parallel. We're not going to do parallelizations over here, but off, it's an option to you can run the parallels. That's a different history. I'm not going to discuss about that. So over here, what I'm going to do is I'm going to the limit essentially is that let's say in a stream has thousands of elements. I want to limit to 100. So how we have to keep track somewhere, right? So that's where we are using counter over here, and we're going to keep counting. And then since we need a state over here because we are passing so op sequential or op methods have a multiple overloaded method. The first one is initializer, and then integrators. So if I don't pass this initializer, because previously someone already asked questions, for example, what if the previous one, for example, this one, right? Let me show you. Where did it go? Sorry. Let me go before limits over here. So op methods, I didn't pass any initialization over here. So that's why it is void, but and that's why we provided underscores. But if we provided any initializers, then that would be our state. So let's go into the limit methods. And so we're going to create the instance of new over here. So this takes a supplier where you provide the your state. Over here, counter is our state, which is going to keep track how many elements we have processed so far. So yeah, and then this again a integrators, which is first element is our state, and the next the element that we're going to get from this stream, and then there is a downstream that basically push elements. So over here we can see we can do state.count. So if it's is smaller than limits, then we're going to create the count plus and then push, and then finally returns. So that's essentially the limits one. So we're just building the how we can build, and then we can go further. So for over here we're doing the limits operation, and there is a caveat over here. As you can see, we limited until 5, right? 2, 7, 1, 14, and 10. But then if you see, the processing is happening for all of them, so that's a problem. So we have to improve that. We have a limit improve methods over here. So what is essentially we have to do, there is a method called is rejecting in the downstream. Ideally, if the gatherer is rejecting, then we don't want to process any further. So that's something you have to add on each whenever you are going to create a custom one. And then the same things, all of them are the remaining same. So if it's limit is smaller than count, count is smaller than limit, then we're going to push. Otherwise, we're not going to push. So the improved one is essentially better over here. As you can see, the second example is the improved limit, and it only processes the amount of we have, the size of the limit. So moving on now. we have done all of those things, right? We can do, I'm going to skip that. So how about we want to do a windowing, for example, this one, right? So we want to, print 1, 2, 3, 4, 5, 6, and 7. So this is how we're going to do that. So the reason I am explaining all of them, one by one, I just wanted to get to this one, which is window fixed. Essentially, I want to a fixed window of, sorry, not this one. Skip that, sketch that. This is a character example. Let's say this fixed window one. So over here, I have a class inside, which is fixed window. And then, there's a, so basically we want to get value like this. 1, 2, 3, 4, 5, 6. And basically we want to partition in a window. So just a list inside a list. So this is our window. And so I have a inner class over here inside the method. So again, I'm going to use sequential over here. And then over here, I'm providing my, state initial. So sequence essentially takes for the initializer. So I'm going to provide the initializer over here. And then the same things. I have a integrators. Sorry. So the first one is our state. So basically, this is our state with the window one, right? This in class. This is our state, and then the next elements, and then we have a downstream. So similar things. If it is rejecting, if downstream is rejecting, we return false, and then we add elements to the window. So this is our window, right? This is a list. We're adding stuff. And then after adding like a few elements, if it becomes this size, if it is a size of the window, right? So let's say my size of window is 3. Then if we have already 3 elements over here, then we're going to pass that 3 elements in the downstream. So I'm going to copy all of them, the state class, and this is a safe copy. You can it's available in the it's an immutable collections, immutable copy basically. So it's create a copy of entire items, and then finally I'm going to clear them, so that we can use the window again for the next window. And then finally we're going to return true because we're going to still continue to collect. And then finally, the last one, it's also an lambda expression, which is essentially a finisher. Let's say over here, right? I took 1, 2, 3. It's the first window, and 4, 5, 6. It's a second window, and then we have also another element, which is 7 available. So what we can do, right? We have to get that as well. So that's where you do the finishers. That's also another lambda expression. So this sequential takes 3 arguments: initializer, and integrators, and then finishers. And sometimes we need combiners when we do the parallel one, but for the sake of time, I'm going to skip that part. So let's go ahead and you can see this is already produced the result. So I'm going to skip the running. What did I? Okay. So that's our window fixed. So we have created our own, but interestingly, we don't have to do that because we already have few built-in available. For example, stream of let's say values, gatherers. There is a few one: window fixed, window sliding, and map concurrent. So these are these 3 method already available. So you can just pass window fixed 3, gatherers just window fixed 3, then you don't have to create your own. So most of the cases, these 3 things will cover most cases. So if you need to create your own, that's why I explained all of them. So and so if you want to run them in a let's say concurrent threads, let's say in a virtual thread, something you want to run in a concurrently, then you can use map concurrent. This is also available. So you can just if I do this one, the following method, this all this is going to use 4 virtual threads to run these operations. So So like if you gather Dutch, some IO related works, basically it takes a by function, right? You can call a function over here, then you can use that. So that's all about this all about the gather. How I am on time. I have a few other um, examples to show you. Essentially, the difference is collector transforms stream into result. Gather enables intermediate stream operations. So it's complex, but you can use this built-in operations for most of the part. But if you need to create your own, you have options. You can do your custom operations. I mean, it's a huge thing. Gather itself requires one lecture, I think. So I'm just trying to show you the demo. All right, I'm going to skip that, and there is another one that I'm going to show you, which is Code Fellow. So let me go over here. So let's say, so the we are familiar with the ThreadLocal, right? For example, we sometimes use do something like that. The benefit of ThreadLocal is so let's say we want to pass a data from one method to another method, and the nesting is deep, really deep, like 10 levels, right? So if you want to pass that value from the top to bottom, you have to do parameterize always, right? You have to pass through the parameter, and now we have to carry all the value, carry the value all through all the methods. That's annoying. Sometimes let's say you are going to use the framework method, and you were going to put some glue method inside these when you were using framework, for let's say you're going to use a Spring framework, and you are passing glue methods for your cases, and framework takes over all of those things. And let's say framework needs to pass some information that also pass through your method. Now you have to carry that variable. The ThreadLocal is essentially give us the opportunity not to do that. Essentially, with ThreadLocals we don't have to carry all those things. Since essentially the whole invocations happens inside a thread, you can just declare a ThreadLocal, and then you can get from anywhere inside that particular thread. The problem is it's a mutable one, and you always forget to clean once you are using, and it can mutate. For example, you declared once and then you can change the value from another places. For example, over here set log level, you have created info. So what happens is we have created a thread local over here, and set levels essentially change the value, right? We can set this. So now we are setting over here, starting the process, and we are inside another thread. So inside the thread, we are changing the debug, right? And if I run this, what would happen? Over here, it should be still debug, right? Let's see. As you can see, um, over here we have set the info, and inside the another thread I have changed it. But this should still be info, right? But you can see it's not. So that sort of issues happens. But with this scope fellow, it's a different. You don't have it doesn't leak anymore, and the you can do the same. You can pass the values, but the all the problem is thread records are no longer available over here. I'm just trying to show you that quickly. I mean, it has I can go on this topic, but let's just quickly show you the demo how you're going to use. So essentially you are going to create a instance of scope value over here like this, request context, a new instance, and then whenever you need to pass something, let's say request context, you have a context over here. So you created a context, and then you're gonna execute like this, scope value dot where, and you are going to pass the reference of your scope value instance over here, and then you provide the value, which is context, and then you call the run method. And inside the run method over here, this essentially create a scope. Whenever you call this request.context, you get this context value. And when this curly brace ends, it doesn't matter how deep it is nested. This is automatically cleaned over here. So it'll not, if you call, let's say, context dot get, you will not get the value anymore, that the one you set over here. So it's a clean, much it's the clean approach, and there's no basically you don't face the problem that ThreadLocal has, which is leaking all those things. And you don't in ThreadLocal it's immutable, right? You can change value from anywhere, and you also forgot that clear it. You don't have to do think about any of those things. It's just automatic. So that's the scope value. This is also available in JDK 25. I think it's available since, it's available since 25, I think, but you can verify that as well. So that's the scope value, which is replacement of ThreadLocals. It's immutable. It prevents memory leaks and automatic cleanup, and it's specially optimized for ThreadLocals performance. The reason is, we can now create a plenty of ThreadLocals, right? So you start, let's say you have created a ThreadLocal somewhere, and then from that place you have created tens of thousands virtual threads. And if you are using ThreadLocal, ThreadLocal is going to be inherited. So that's a lot of new memories, right? They're going to copy the value. But with this, this is optimized in scope value, so you don't have to worry about those things. All right, you can obviously use that as scope value in virtual threads as well, especially with the structured concurrency. So this is how we're going to use. I'm just showed an example over here. Let's say you have a request ID and that current users to scope value, and you can use them automatically over here. So this is specially suited. It's a sweet spot for structured concurrency. So try it out. Okay. So moving on, there is another new features called stable values. This is really interesting. I think I have a questions over here. When will this ping support JDK 25? Well, JDK 25 is not released yet, right? I'm using the early release version. So if you want to, once it is released, hopefully they will catch up, and they're pretty fast. So hopefully next year we will be able to use them using JDK 25 for Spring. So the idea. Okay, so moving on, there is another question. Okay, I'll skip that question for now. So there is another interesting new feature called stable values. The stable values essentially, improve the startup time. The idea is, let's say I have this expensive resource over here, right? If you want to create an instance of this expensive resource, take times, because it does. I'm simulating over here with ThreadSlip. Let's say it create a bunch of other objects and all those things. It takes time, right? So now, if I use this expensive resource, like somewhere, let's say something like that. Let's something like this, a new expensive resource, and let's say I name it, let's say final. Now when application is going to start up, right, they're going to create this expensive resource. Maybe we don't need it immediately, but it's going to create anyway. So that will reduce the startup time. It will take time to if we have thousands of thousand is pretty big number. Let's say I have a 10 expensive resource, something like that. That takes time. So when application is going to start, they're going to create all of them, and it will take time. So startup time will be longer. So there is alternative way that we used to do, which is this way. So we lazily start them, right? Something like that. So whenever we need the get resource, we'll just first take the null, and then we'll create this is the old way, but it has certain downsides. It will create it's not thread safe, first of all, and then there's other consequences. But the new way is you create a value, something like that, stable value. This is a new API. You pass that expensive object over here, and then you create like stable value of off. Now, whenever you are gonna call this get resource, you are going to do something like that, resource, or else you create this. So this is going to differ the instantiation, and this is going to make sure that we don't have multiple copy of expensive resources. And once it is initialized, it's fixed, it's immutable, and then we so um, this is the guarantee it provides. This way it's much more safe, essentially. And then, since we're deferring the instantiation of the expensive resource, start over is going to be faster. So that's another new feature that I wanted to share with you. Okay. So there is another demo that I want to show you, which is really interesting, which is called native library demo. So essentially, um, this is not in my slides, but since it is over here, I just wanted to show the demo. The idea is we can call native libraries easily now, without going through the JNI process. JNI was pretty uh, delicate process, and it was easier. It's pretty easy to make mistakes. And with this process, with this new foreign functions and memory, it's just all Java object, and you can call them pretty easily. The API itself, it's the imperative API. It takes some learning, but the benefit is we don't have to go through the JNI anymore. It's just plain Java classes, and you can do a lot of interesting stuff. For example, this one is you can declare start over here like this. And I'm going to share all of you the code base, so you can try it out, and then you can do call native methods from Java. And while you are doing that, if you need to call some Java method, you can do a callbacks, and you can do all sort of complex operations. So um, before doing that, I'm going to show you a demo over here. So let's say I have a class over here, which is written in C, and I have this header over here. So it has struct type def in a point, and it uses it has a fixed origin over here, and it has certain methods over here. For example, pointer, create method, display, and all of those things, and created a library out of it, which is over here, lib geometry daylib. Uh, and Yeah, so if you can create library like this, and you can also access any portable library, right? And then there is a library called jextract. You can execute this method, jextract. I paste it over here, and then you can provide it this parameter. So this is essentially, this is going to help me is it's going to create all these necessary classes that I require to invoke these methods. For example, as you can see, it created all these classes, Java classes. I can then directly use that. And there is a pointer over here. So this is what I did over here. Now I'm just loading the library from here directly, and then I can call this. For example, I can call this distance. I'm going to create a point using the 1 2, and then I'm calling this method directly. So all this Java code essentially, but this is distance origin is happening in the native code, and we're just calling the native code like Java. So that's another interesting aspect. This is called foreign function, FFM, foreign function and memory API. You don't have to rely on unsafe. You don't have to rely on magic. You can just use pure Java. So that's another new feature of Java. You can definitely use that if you need to call native API. And okay, so finally, I think I already went over the time, so I'm going to quickly finish these slides. Uh, this string template is gone, unfortunately, and I'm sad about that. Hopefully, in the new JDK, they're going to take initiatives and write it a new way. So that I just wanted to show you that. And in JDK 23, it's now you can write the comment in Markdown. That's a new enhancement. There's tons of performance benefit. You don't have to use you don't have to change any code, but you are going to get all these benefits. For example, ahead of time class loading significantly improves startup. So startup time is going to be faster. Compact object header, arguably there is a statistics. You were going to get in like 25% less memory uses if you just use compact object header. It's require additional parameter JVM argument, of course. So these are the benefits you are going to get without any code changes. If you just change your JDK version to 24, you just get them out of the box. So these are the extremely significant and beneficial outcomes. And there is also garbage collection enhancement you can check. ZGCs now have generational modes. You can achieve a lot of reduction in allocations and all these nice features available. You can just try and see if just do an experiment, see how far you can achieve, how much improvement you can achieve. Obviously you need to do that experiment before putting them in production, so do that. And also make sure in JDK 24, security manager permanently disabled, so don't rely on it. And also don't use unsafe. It's unsafe since the beginning. Whenever unsafe itself says it's unsafe, so don't use unsafe. A lot of library use that. There is an alternative API which is foreign function and memory API, so use that instead of unsafe. So these are the example. How can you allocate, for example, the region people use unsafe to allocate some native memory, right? So you can use that using FM API now, which is point function and API. So you don't have to use unsafe anymore. Moving on. So that's all the demo I had. Yeah, that's all the information. If you want to reach out to me, please go through. There is a LinkedIn URL over here, Twitter, my website and my GitHub account. Also, I'm writing a book right now, which is modern concurrency in Java. I provided all the glimpse over here about the concurrency, right? Structured concurrency, virtual threads, and other things, scope value, all those things. But I have written great deal in this book. It's available in the O'Reilly platform. Hopefully in September, it's going to be available as a printed version, and I'm looking forward to that. It's been a long journey. So yeah. And finally, I'm actively looking for new opportunities. If you see any opportunities, feel free to reach out to me. I'm a Java developer, so I can take any Java related work. I enjoy Java. I write, even breathe Java. So anything related to Java you see, please reach out to me. Thank you very much. That's all I had. I'm going to show you the. I'm going to show you the. Give the repository. I'm going to share with you all, and then you can definitely try all of them, all the experiment that I did.
Sure. Bazlur, very good.
Brother, your voice is breaking. I think you have to, if you want to rejoin, just yeah, your voice is pretty. I can't hear you anything. I don't hear anything from you. Now you are muted.
Brother Bazlur, can you hear me?
Yes, I can hear you now.
Thank you so much for this great content. Very nice presentation. It's for me, it's first time really I know about these wonderful features in Java. It's really Java is changing and it's becoming very concise and beautiful. So thank you so much for this great presentation. I don't know whether there are some questions here. There's one question: what if the task is transactional annotated? Let's say that there are 3 tasks: T1, T2, T3. It's like database transactional. If one of them fails, so is it going to be a rollback, or I think this is like up to your implementation, right?
Right. It's up to your implementation how we're going to do that. There is a ways. I mean, you can definitely configure how you want, but yeah, it's up to your implementations.
Yeah, indeed. There is a question from me. What is the plugin that you're using for auto completion the code?
Okay, I actually don't know which plugin currently I'm using because I have a few
Oh,
AI tool over here. For I'm using JetBrain AI. I'm using Gemini. I also have Claude. A few. I mean, basically, I've been trying with multiple plugins. So I'm not sure which one is currently being kindly is
works.
being used here. But yeah, I have also Copilot as well. So
Mhm.
yeah, so I've been trying with this all these AI tools available out there.
Amazing.
So pretty much I have installed all of them and trying to take benefit.
Good site. There's one question from Amit. He's saying, do file and socket operations
I think
yield
I
the
I
platform?
think
Yeah.
I replied
All right.
that already. Yeah.
Okay. Nice. There is also one question from my mind. I'm sorry.
Sure.
How it's gonna be the transitioning? Like if I'm using Java 17 or Java 21, I want to jump to Java 23 or 24. Like, is there any way direct migration, or I have to like migrate manually the stuff?
I mean, if you want to use, for example, if you want to use, let's say, structure context, for example, right? You have definitely old code base. It requires change, code changes. So in that case, we're going to have to make those changes, right? But some of the features are, available out of the box. For example, if you're going to use JDK 24 and you want to achieve those performance benefits, you don't have to do any code changes. So you do just try your applications in your, let's say, first of all, in your sandbox environment or staging, let's see how it behaves, and then pretty much once you are confident enough that it doesn't break anything, you can just use them. One example I can show, like when we are using JDK 21, so we are using Spring Boot applications, right? And Spring Boot provides a flag that way you can just automatically use virtual threads for all of them. Now the question is, we are using some third-party application, third-party libraries, and they are heavily dependent on synchronized keyword. And like synchronized keyword is definitely a performance issue. You have to also measure how long it blocks. Like it's a few milliseconds, that's fine. But if it takes like 100 milliseconds on a then that's a problem. So
Mhm.
so let's say you have a synchronized method that calls another microservice inside that synchronized method. That shouldn't happen, but if that's the case, then that's a problem. So what we did is we add additional flag, the flag that I shared in this talk, which is trace pinning. So and see the behavior, how all the where it's actually printed, and then also you can check I mean, there is a few other flags that you can use to measure how long it takes, right? And if that was an issue back then, so we didn't use virtual thread for particular region, because we had to either, the option was either we have to change the third party library that you, or rewrite this functionality. That was a that would took a long time, and it requires effort. So we didn't decide to use virtual thread, but we use JDK 21 anyway. Now that right now we if we want to use JDK 24, the issue is resolved, so we can just use JDK 24. So it's a, I think the transition, the personally, I feel like you should always use the latest JDK. That way, you are always using the latest feature ahead of time. I mean, you are always closer to the next LTS, right? So you don't have to do a lot of hard work when your new version is coming. I try. I mean, I personally love this approach. Whenever the new JDK comes, let's try using it. Let's see if it fits our use cases. Then let's say I'm using 24 now. 25 is LTS. I can quickly shift to 25 easily. So most migration, in my opinion, a few example of course required code changes. For example, if you want to use scope value, if you have a lots of use case of ThreadLocals, that's not going to happen quickly. You have to change the code and then you have to do the testing. Also, if you want to use structured concurrency, you have to make the changes. But if you want to use let's say you are using Spring Framework, and Spring Framework allow to use virtual thread with just one flag change. You can try and experiment that.
Yes, this sounds good. It's a very practical guide to do this. All right. So with this being said, here we conclude our session. Again, thank you so much, Bazlur. If you have any final words to say.
No, that's all. That's all. I enjoyed, speaking to you, and I love all of you who joined. Let me know if you want to have another session future. I'm always available. I can go deep down on concurrency, structured concurrency. I can take a whole session on Gatherer API. Also, I'm also looking into large language model nowadays. LangChain4j. LangChain4j is one of the topic that I am exploring right now. I'm also writing a book on that. I have a co-author named Shaf. He is my friend. We're writing a book together on Java integration with LangChain4j. The idea is how can we? I mean, everyone thinks about that. If we want to integrate LangChain4j to our system, we need to use Python. That's not true. We can use Java. It's pretty, it's really stable and a matured ecosystem nowadays. So you don't have to move to another programming language if you want to. If you're a Java shop, you can just. If you want to integrate with LLM, you can just do it using Java. So that's another topic that I'm currently exploring. So if you want to have another session with that, let me know. I would love to talk with you all of you guys. I mean, I enjoy talking about things I love.
That's really sounds very, very interesting. And here we tell our audience that inshallah we can make it either in August or in September, that have a session dedicated on LLM.
Yeah, I'd love to.
Yes.
And I'm going to share the code base with you, and then you can put in the description of this YouTube video so that anyone wants to experiment can do that. Also, it's probably available in my GitHub repository, but I'll double check and share with you. So thank you everyone for joining. Assalamu alaikum.
Wa alaikum salam. Thank you so much, guys. See you inshallah in the next session.
Take care. Bye bye.